Hi, I'm now going to go over question 7 of the arcs and sectors assignment. It says a path runs around part of a circular lawn which has a diameter of 15 metres. Okay, so we've got a diagram here, we've got a circle here with a diameter of 15 metres. We've then got this, part of a circle running round here. And the angle here is 135 degrees. Okay, the larger circle has got a diameter of 19 metres. Okay, so that's quite a lot of information and you need to kind of work out what to do to solve the problem. So part A says find the total perimeter of the path. So the perimeter of the path is made up of the length of that arc there, plus the length of the bigger arc here, and then you've got that wee bit there and that wee bit there to add on to get the perimeter all the way around the path. This wee bit here and this wee bit here is made up of the difference between the diameters of the two circles. So the wee circle goes 15 to 15, the big circle goes 19 to 19, so the difference between those is 4 metres. So you've basically got, if you split that in two, you've got 2 metres here and then you've got 2 metres here. Okay, so we need to find the length of the arc of the smaller circle here. We'll start with length of arc. So it's going to be a fraction of the circumference of the small circle. So I'll say length of arc 1, I'll say. So the fraction's made up of the size of the angle over 360 degrees, but remember it's not the 135, we're looking at this arc here. So if we were looking at that bit there, we would use the 135, but because we're looking at this bit here, we need to do 135 away from 360. So before we start, let's just put that here, 360 degrees, take away 135 degrees equals 360, take away 135, 225 degrees. Okay, so that's the angle we'll use for the length of the arc. So we have 225 out of 360, that's our fraction. Sorry, I should really write the formula down first before I start. So length of any arc is theta or x over 360, so the fraction times, now it's part of the circumference and circumference is pi d, so that's what we're using. So the angle we're using is 225 over 360 times pi times the diameter. So remember, we're looking at the wee one just now. Diameter of the wee one's 15. Okay, so when you put that into your calculator, 225 divided by 360 times pi times 15, we get 29.45. I'll just round that to 29.5, and it's all in metres. Okay, so that's from here round to here, I'm calling length of arc 1 is 29.5 metres. So we need to do that again for the bigger circle here. So length of arc 2, again formula, and then put the numbers in. So the bigger circle, it's still the same angle size, it's still this angle here. So it's 225 over 360 times pi, but this time the diameter of the bigger circle is 19. So when we calculate that, 225 divided by 360 times pi times 19, we get 37.3. Okay, so that's from this point here all the way around to here is 37.3. We're trying to work out the total perimeter of the path, so perimeter is going to equal this wee bit here, so 29.5, these wee bits here and here, so plus 2, and then the bigger bit round the outside there, 37.3. So when we add all that together, 29.5 plus 2 plus 2 plus 37.3, we get 70.8 metres for the perimeter of the path. Okay, so that takes us all the way around there, up here, all the way around here, and along there to back to where we started. Right, part B says the area covered by the path. So we're going to have to work out the area of the whole big, oh no, sorry, the whole big circle, the area of that sector of the big circle. Then we work out the area of that sector of the wee circle. And if we take that away from the big one, we end up with the area of the path. Okay, so we need area of sector 1 equals. So we started with the smaller one and the one above, so we'll keep with the way we did it there. So the area of this sector here, the wee one here, is that there we're looking at. So it's area of a sector is theta over 360 times pi r squared. So our angle's still the same, 225 over 360 times pi times. Now the radius of the smaller circle, diameter is 15, half of 15 is 7.5. Okay, so if I put that in the calculator, 225 divided by 360 times pi times 7.5 squared. Answer is 110.4, and that is square metres. Right, so now we're going to work out the area of the bigger circle sector. Now that includes the green bit when we work that out. It's basically this sector here, and we'll work out the area of all that, including the green bit there. Okay, so area of sector 2, it's the same formula we start with. This time it's 225 over 360 times pi. So the big circle has got a diameter of 19. Half of 19 is 9.5. And that's got to be squared. Okay, so 225 divided by 360 times pi times 9.5 squared equals 177.2. And that's square metres. Okay, so we've got the area of that sector there, and we've got the area of the bigger sector there. So in order to work out the path bit, we've got to take the area of that green bit, the small one, away from the area, the whole area of the big one, so we get the area of the path. So area of the path is going to be the 177.2 subtract 110.4. So do that, 177.2, take away 110.4, 66.8 square metres. Okay, so that was quite a lot of work in that last one. Well done if you've managed to follow all of that and you understand what's going on. Thanks very much. Bye.